Hello friends, very good morning. And in today's video, we are going to learn about the conversion of the given orthographic views. When I say orthographic views, it includes the front, top, and end views to an isometric view. So friends, in this a simple block is given and the dimensions of the block is also given here. And looking at these three views, we should be able to obtain the isometric view of the orthographic views given here. Now friends, basically what we do, we are going to write down 30-degree axis here and mark on this horizontal axis, that is inclined axis, the maximum dimension. You can see the maximum dimension is 60. The height of this is equal to 50. That can be seen both in the front and end views. And the width is equal to 45. So friends, this is very essential. Whatever may be the given question where the orthographic views are given, you have to write down a box which will have the length, width and height to the given dimension. Friends, if you see here, if you are looking in this direction, is the front view. There, if you observe the front view, there is a C-type cut here. Where is that? On the top, if you see friends, you are going to have here a line, and in this line which is at a distance of 20 millimeter from the end, from this end, it is 20 millimeter, and exactly in the center of that you have a C-type cutting here. So we have to extend this and obtain that C-type cutting in that. So friends, I am going to have this drawn here to the given dimension. So and obtain this portion in the box at the top. So friends, this is a part of this isometric view. You can see here friends, here this dimension is totally 20 and this is 10, and this width is equal to how much? 10 again. So this is 10 and this is also 10 friends. Now friends, from here there is a sloping surface and you can see three rectangles here. This is open in the center and there are three sloping surfaces from this till here. Friends, whatever the distance you have got here, that is, this is totally 45 split into 3. So 15, 15, 15. I will just mark in the bottom of this box distances of 15, 15 and 15. And now friends, I am going to join this to this end, that is this to this, by a straight line. And similarly friends, from all these corners, again from this I am going to join to this. Is again a sloping surface. Again from here to here on the sloping surface you will have. And from this again a sloping surface till here. Friends, you have got these three sloping surfaces and this is open here. Friends, now you can just see here friends, this from this corner you have a slot here like this. So I am going to draw a line parallel to this base through this point and it will cut somewhere here. And friends, again from this corner I am going to write down a vertical line from there, a vertical line from that which is parallel to the vertical line here. Say maybe something like this you get friends. So there is a slot cut here and this is one sloping surface which is of width 15 and the total width is equal to the 60, this dimension, and this is open in the center, and all these dimensions measure 15, 15 and 15. Friend, if you look from the top, you can see the C, and here you have got these three rectangles, sloping surfaces, and a small change here. This is the sloping surface you got, friends. Now, friends, we have this line. This can be completed. So I will draw a line here to complete that. Then this vertical height I will show by a dark line, and again this will be shown by a dark line. Friends, you got this? Now, friends, here in the front view, you have got a slot of 20 with height 10, and that is there at a distance of 40 from there, friend. From here, you take a distance of 40 millimeter, say up to here, and then we have to construct a rectangular slot here of height is equal to, that is 10 millimeter height. So I will show here 10 millimeter height, and this has got a width is equal to 20. 20 is the width, and this slot exists at a distance of 40 millimeter from the extreme end. So from here to here, this has to be 40 millimeter. So we have got this, friends. Once we have a slot there, friends, we have to remove this line from there and show or draw a line parallel to this. So this will indicate that there is a rectangular slot cut throughout width of 45 millimeter, and that is shown by these two dotted lines. Dotted line, dotted line. There is no material here, and hence I have not shown anything there. Friends, if you compare this with this orthographic views given, you will be able to find out whether the isometric view you have got is completely correct or not. Friends, please look at this front view. In the front view, there is a width of 20 mm here, and there is a sloping surface. This line indicates surface 1, surface 2, and this surface also. It is showing all these, friends. And then after that, friends, you have got a slot here. Slot is having a width of 20, thickness 10, cut at a distance of 40 millimeter from the extreme end, that I have shown in slot, and that is seen as two dotted lines. This I have already explained. Friends, if you see in the end view, friends, you can see one sloping surface, second sloping surface, third sloping surface, each having a width of 15 millimeters. All these are 15 mm each. And this dotted line here is not visible in the end view, and hence at a height of 10 mm in the end view, I am going to have a dotted line here. So this height is equal to 10 millimeter. Is that's why. Friends, this is how we obtain the isometric view of a solid whose orthographic views are given. And friends, remember, it's a convention in isometric view or isometric drawing not to show any of these angles, but these dimensions can be marked. Major dimensions like the width, the height, and the length can be marked. Friends, this view, the isometric view, satisfies all the requirements of the orthographic views given here, and the solution you have got is completely correct. And whatever these lines I have written here, these construction lines, can be removed to give a better look forward drawing. So this can be removed, and you will have better understanding of this particular component. And when you see again, you will be able to get what the view is. So friends, this is finally the view you have, and this satisfies all the requirements that are given in the orthographic views. And this is how it looks, friends. Friends, I hope the presentation was interesting. Please go through the complete video, and in almost all universities across the country, there are two methods of asking this question. Given the isometric view, they will ask you to draw the orthographic views of the solid or any of the component, a casting, etc. Or given the orthographic views, you will be asked to draw or obtain the isometric view of the solid. If it is isometric view, you have to make use of the actual dimensions here. If it is isometric projection, whatever the dimensions you got here are to be taken as a dimension into 0.815. Generally, in isometric projection, the dimensions in all the directions get reduced by approximately 18.5. So, what are the dimension you have got here? For example, 60 you have got here. If you are writing isometric view, you have to take 60 only. So this 60 actual to be taken while constructing this box. But if you are making isometric projection, then this 60 is to be multiplied by 0.815. So approximately this 16 becomes equal to 50. So that's how you should know the difference between the orthographic views, orthographic projection, isometric projection, etc. Friends, go through the complete video, and if you like this video, do share about this video and about my YouTube channel with all your friends. Have a wonderful day. And this is Dr. M. H. Chennaiya signing off.